Hey Algebra 1, we are now continuing on from Lesson 9 to Lesson 10 into Lesson 11, continuation of a lot of the same thing. Today we're talking about conditional relative frequencies and association. We're going to calculate and interpret conditional relative frequencies from two-way frequency tables. And then we're going to evaluate conditional relative frequencies as an indication of possible association between two variables. We're going to explain why association does not imply causation. Okay, sort of our big takeaway from this lesson. First of all, after further discussion, the students involved in designing the superhero comic strip decided that before any decision is made, a more careful look at the data on the special powers a superhero character could possess was needed. There is an association between gender and superpower response if the superpower responses of males are not the same as the superpower responses of females. Examining each row of the table can help determine whether or not there is an association. So association, okay, can determine whether or not there is an association. So let's recall the two-way table from the previous lesson. Okay, 450 random surveys were pulled, and students were asked whether they wanted superhero power of flying, freezing time, invisibility, super strength, or telepathy. And we separated those between males and females. So let's talk conditional relative frequency. A conditional relative frequency compares a frequency count to the marginal total that represents the condition of interest. So frequency count compared to the marginal total. For example, the condition of interest in the first row is females. Condition of interest in the first row is females. The row conditional relative frequency, so just the row conditional relative frequency of females responding invisibility as the favorite superpower is 48, which invisibility, over 228, which is the total number of females that were surveyed, or approximately 0.211. This conditional relative frequency indicates that approximately 21.1% of the females prefer invisibility as their favorite superpower. Similarly, 27 over 222, or approximately 12.2% of males prefer invisibility as their favorite superpower. So we are doing conditional relative frequency compares the rows. So the frequency count to the marginal total. So use the frequency counts from the table in Exploratory Challenge 1, the previous slide, which I put right there, to calculate the missing row of conditional relative frequencies. Round the answers to the nearest thousandth. So for each of these, we're going to take the frequency over the total number of females. So you would calculate that out. Freeze time, super strength, telepathy, and then here we would have 228 over 228, which is 100%. Freezing time, 71 over 222 males, 27 over 222 males, 25 over 222 males, and telepathy, 48, 222. And then this last row, 100 over 450, or 131 over 450, 75, and then 26 over 450, 118 over 450, and 450 over 450. Okay, what I'm going to do now is erase these, and this actually asked you to round your answers to the nearest thousandth. So I'm going to push pause, erase these, and put the actual answers in. All right, there you go. I would jot those down really quick, and we're going to use the information, so jot them down so we can move on. Suppose that a student is selected at random from those who completed the survey. What do you think is the gender of the student selected there? So let's start there. Well, since we had 228 females and 222 males, I believe that we have pretty equal chances of getting a male or a female. What would you predict for the student's response to the superpower question? If I look at the total, the bottom row of that table, the one with the biggest number or the highest percent was in fact freeze time. So that would be my guess as to which of the superpowers the student had selected. Because it was selected by more of the males and females added together than any other superpower. Suppose that a student is selected at random from those who completed the survey. If the selected student is male, what do you think was his response to the selection of a favorite superpower? So just the males, the largest number I see is freezing time. Okay, just for males, that is 32.0%. It's the most popular selection for male students. Suppose that a student is selected at random from those who completed the survey. If the selected student is female, what do you think was her response to the selection as a favorite superhero power? Explain your answer. So we'll go back and look at the table. I'm looking for the largest female answer, and it looks to be telepathy at 30.7%. So that's the most popular selection for female students. I already answered number 4. Yep, number 5. What superpower was selected by approximately 1/3 of the females? 1/3 of the females is 33.33 repeating percent. In telepathy was selected by approximately 1/3 of the females, because if you look at the chart, it was 30.7%. Freeze time was selected by approximately 1/3 of the males. What was that one? So this one was for females, and that was for males. So freeze time was selected by approximately 1/3 of the males. These selections were based on row conditional relative frequency approximately equal to 0.333 or 33.3. Okay, moving on. Two categorical variables are associated if the row conditional relative frequencies or column relative frequencies are different for the rows or columns of the table. For example, if the selection of superpowers selected for females is different than the selection of superpowers for males, then gender and superpower favorites are associated. I'm going to say that again. If the selection of superpowers selected for females is different than the selection of superpowers for males, then gender and superpower favorites are associated. Okay, then two variables are associated. Go back to the beginning. Two categorical variables are associated if the row conditional relative frequencies are different for the rows of the table. Two categorical variables are associated if the column relative frequencies are different for the columns of the table. This difference indicates that knowing the gender of a person in the sample indicates something about their superpower preference. The evidence of an association is strongest when the conditional relative frequencies are quite different. If the conditional relative frequencies are nearly equal for all categories, and there's probably not an association between the variables. These are all things you're going to have to remember. Examine the conditional relative frequencies in the 2A table of conditional relative frequencies you created in exercise 1. Note that for each superpower, the conditional relative frequencies are different for females and males. Okay, for what superpowers would you say that the conditional relative frequencies for females and males are very different? Looking back at that table, the most noticeable difference is for invisibility. We've got more for super strength. I'm going to go back and get the values. And then telepathy. The most difference between the males and the females are between invisibility, super strength, and telepathy. If I go back and look at the table, invisibility, I've got 21% for females, 12% for males. Super strength, 0.4% for females and 11% for males, big difference. And telepathy, 30% for females and 21% for males. Big differences there. You know, looking back at the table, you might be able to argue freeze time, too. So for what superpowers are the conditional relative frequencies nearly equal for males and females? Flying was about the same for males and females. If you look at the table, flying is 21.5% for females and 23% for males. That's pretty darn close. And then number 8, suppose a student is selected at random from the students who completed the survey. Would knowing the student's gender be helpful in predicting which superpower this student selected? Explain your answer. Due to the differences in the conditional relative frequencies of selecting a particular superpower based on gender, it would be helpful to know. It would be helpful to know the gender. It might help us narrow down the prediction of selecting a superpower. It would help us narrow down the prediction. Is there evidence of an association between gender and a favorite superpower? Explain why or why not. We just talked about the definitions of association. And the definition, I'm going to read it again. I know I'd read it a ton of times, but one more time. The evidence of an association is strongest when the conditional relative frequencies are quite different. If the conditional relative frequencies are nearly equal, then there's probably not an association. Okay, but evidence of the association is strongest if there's a large difference. So for number 9, there appears to be an association. Can't spell. What superpower would you recommend the students at Rufus King High School select for their superhero character? Justify your choice. You could pick anything as long as you justify it. If I look at the relative frequencies, I would look at the ones that would hit both the females and the males, and it looks like, goodness. I mean, if you did freeze time, you would get 29.1% of the entire population. But really, I mean, telepathy isn't that far off, except telepathy, there are definitely more females than males that pick telepathy. So you could really argue anything as long as you give it a good justification. All right, exploratory challenge number 3. Students were given the opportunity to prepare for a college placement test in mathematics by taking a review course. Not all students took advantage of this opportunity. The following results were obtained from a random sample of students who took the placement test. So if you look, I've got took the review course, did not take the review course, placed in Math 200. Okay, took it, didn't take it, placed in Math 100. Took it, didn't take it, placed in Math 50. So we talked to 100 students. 60 of them took the course, 40 of them did not, and then how many placed in each specific math course. So first of all, let's construct a row conditional relative frequency table from the above data. So I had 40 that took the course out of 60, 10 who did not take the course out of 60. That gives me 0.667, 0.250, and then we had 50 out of 100 placed in Math 200. That's 0.5. Okay, 13 out of 60, 15 out of 40. Oh, that's a mistake there. So sorry about that. What did we have? 10 out of 40. That math didn't work out, did it? This gives me 0.217, 0.375, and then we had 28 placed in Math 100 out of 100 kids, so 0.280. 7 out of 60, 15 out of 40, that gives us 0.375, 0.117, and then 22 total out of 100 is 0.220. We should always have 100 or 0.100 in that corner. Nope, that's not right. Huh. We should always have 1.00 in that corner. $40 out of 40. And technically, so you can see how the math works, 100 out of 100. Sweet. Based on conditional relative frequencies, is there evidence of an association between whether a student takes the review course and the math course in which the student was placed? Now remember, we want to know if there's an association. So is there a big difference? I would say yes, there is evidence of an association because the conditional relative frequencies are noticeably different for those who took the course. So if I look all across here and compare it to all across here, there is a very big difference for those who took the course and those that did not take the course. So big difference. Looking at the conditional relative frequencies, the proportion of students who placed in Math 200 is much higher for those who took the review course than for those who did not. One possible explanation is that taking the review course caused improvement in placement test scores. What is another possible explanation? Oh, I hate questions like this, right? Another possible explanation, let's think. Maybe students that took the course, they like math. They like taking extra courses because they like the math. So they like math, they took the course, they placed higher, they were already better prepared. I don't know. Those sound like good ones. All right, now consider the following statistical study. 50 students were selected at random from students at a large middle school. Each of these students was classified according to sugar consumption, high or low, and the exercise level, high or low. The resulting data are summarized in the following frequency table. Calculate the row conditional relative frequencies and display them in the table. So we'll go ahead for sugar consumption high, exercise level high. 14 out of 32 total. And then we're going to have 18 out of 32 total. And then 32 out of 32 total. This gives us 0.438, 0.563, and a 1.000. The next one, I have 14 out of 18, 4 out of 18, and of course 18 out of 18. That gives me a pretty high number here, sort of low number there, and a 1.000. And then the last one, I have 28 out of 50, 22 out of 50, and 50 out of 50. That gives me 56.440 and 1.000. Okay, let's use this to answer some questions. Is there evidence of an association between sugar consumption, category, and exercise level? If I look at sugar consumption and exercise level, there is a noticeable difference. On the conditional relative frequencies based on whether a person selected high or low sugar consumption. The differences suggest that association. So when there's a big difference, there is an association. Is it reasonable to conclude that high sugar consumption is the cause of the observed differences in the conditional relative frequencies? What other explanations could explain a difference in the conditional relative frequencies? Explain your answer. Let's think. Based on what we know, we really can't interpret cause and effect. Based on what we know. We don't know enough. I mean, we could talk about eating habits, lifestyle, all those things that could be mentioned, we could discuss, and how that would affect it. Yeah. All right. To summarize, a conditional relative frequency compares frequency count to marginal total. Okay, that represents the condition of interest. The differences in conditional relative frequencies are used to assess whether or not there's an association. The greater the differences, the stronger the association. An observed association between two variables doesn't necessarily mean there's cause and effect between the two variables. Okay, awesome, good work.